Okay, so today we're going to be talking about how we solve radical equations. Really goes along the lines of what we've been doing for the past week or so, so it shouldn't be too difficult. Let's go ahead and move to 1.3. Okay, so here's my first radical equation. How do you think you solve it? What do you think? We want to get that radical x by itself. Yeah, so how do I start? Add 3 over. Good. All right, that's a great start. Now what? How do I get rid of a square root? I square it. Good. So I'm going to go ahead and I'm going to square just the left-hand side? No, I got to square both sides, right? So I'm going to square the square root of x, square the 3, and I get x equals 9. What do I absolutely have to make sure that I do? Have to make sure I check it, okay? And if you want to store 9 and see if it checks that way, you can do that. If you want to plug it in by hand and see if that works. What's the square root of 9? What's 3 minus 3? Does it check? So my solution is 9. What do you think? Not really. Not too bad. Okay, so how do you think I would solve this graphically? Put what in? That. What do you mean that? You got to be a little more specific. Which part of the equation? Okay, so I'm gonna graph the square root of x minus 3. What else? Can't just graph that. Is that going to solve anything for me? No. What else do I need to graph? I need to graph y equals 0, right? So what am I looking for when I have these two things graphed? Good, I'm looking for the intersection point. What should my intersection point be based on what my answer is? Yeah, my intersection point should be 9, 0 if I'm correct. Does that make sense to you guys? Okay, so let's go ahead and on the next page, we're going to graph each half of this equation. So square root of x minus 3. So there's my square root function, right? What else am I graphing? 0. Y equals 0. So there's the other half. What am I looking for? The intersection point. How do I find it? Menu, geometry, points and lines, intersection point, click, click, and there it is. So were we correct? Whoa, didn't mean to do that, did I? I can undo that. Okay. Were we correct? Absolutely. Okay. So you can solve it you can check it graphically, you could check it with numerical solve, you can check it by storing, or you could check it by hand. So is there any reason to get any of these incorrect? No. All right, so let's try another one. How do you think you start with this one? Not yet. Yeah, what's the goal? What's your initial goal? Good, to isolate that radical, right? We want to get the square root of x plus 2 by itself. So we need to move everything else away from it first. So again, what's my first step? Add the 4. Good. Divide by the 2. Very good. Square it. Be careful with your vocabulary, guys, especially when you get to these process essays, right? If you say square root it, what you're telling me to do is to take the square root again. Is that what you want? No. So what do you have to do? Square it. Okay, so watch your vocabulary, okay? Okay. Subtract 2, very good. All right, so how would you like to check it? You could check it graphically, you could check it using store, you could check it using numerical solve, you could check it by hand. Choose one and do it. Okay? Okay, so it does check. We get 2 square root of 2 plus 2 minus 4 equals 0. We get 2 square root of 4 minus 4 equals 0. Or 2 times 2 minus 4 equals 0. 4 minus 4 equals 0. 0 equals 0. Checks. Is it easier to just do store? Yeah, it is. But you have to know how to do it both ways. Okay? All right, let's try. So there it is graphically. Okay. Let's try another one. Go ahead, give it a shot. First step. Subtract the 5. Second step. Good. Divide by -1. Third step. Fourth step. How many of you got that? Fifth step. Does it check? Problems, questions, concerns? Good. Let's move forward. Okay, try this one. First step. Good. Divide by -3. 0 divided by anything is? Any problems with that? Next step. Square both sides. What's 0 squared? Next step. What do we get? Okay, does it check? Any questions? Okay. Yes, a little bit. Just a little. All right, try this one. This one should be very quick. First step. Subtract that 1. Second step. So you got x equals, what's the square root of 1? What's 1 plus 1? Does 2 equal 0? So what do I have to do with x equals 1? I have to reject it. So is there a solution? No. Who graphed this? Ah, okay. So let's take a look and see what, make sure it's on your calculator. Let's take a look at what Brandon's calculator looks like. Okay, so here's Brandon's calculator, right? Brandon graphed it wrong. He's gonna fix it right now, so he can show us what it really looks like. Okay. Okay, so here are your two functions, right? What do you notice? They don't intersect. So is there a solution? No. No, so no solution. Okay? Good. Thank you, Brandon. The second time. Okay. So is there a possibility of there being no solution at all? Yes. Is there a possibility of there being more than one solution? Yes. Yeah. Okay, all of those things are possible. So let's get a little bit harder. Over there by the window. All right, so I've got the cube root of x minus 2 equals 0. So it's not the square root, it's the cube root. But does that really change how we solve it? You're going to skip ahead to 2.2, guys. Or wherever it is, wherever you get to this one. Probably not 2.2 on yours. Yes? Okay, so the cube root of x minus 2 equals 0. How do I start this? Add the 2. Good. Good. So in order to get rid of a cubed root, I have to cube it. So we're going to cube both sides. And we get x equals 8. No. I definitely said no. Okay, so we're going to check real quick. Cube root of 8 minus 2 equals 0. What's cube root of 8? What's 2 minus 2? Does 0 equal 0? So it checks. Okay? So that's a good question. How do I graph this? Well, we've got the cube root of x minus 2. So we're going to go ahead, Control G, cube root, Control caret, All right. Cube root of x minus 2. So that's what a cubic looks like. Okay, they all look like that, every single one of them. And then we're going to have 0. And what again are we looking for? The intersection point. Menu, geometry, points and lines, intersection point, click, click, and we get the point 80. So were we correct? Okay. So how do I get rid of a cubic? How do I get rid of a square root? Okay, so just a quick reminder here. Square root of x is the same thing as x to the what power? 1/2. Cube root of x, same thing as x to the... Okay, now, pay attention very closely. Are we paying attention? How do I get rid of a square root? So how would I get rid of x to the 1/2? What's 1/2 times 2? 1. How would I get rid of a cube root? So how would I get rid of this one? 1/2 and 2, 1/3 and 3. What are they in relation to one another? They're reciprocals. That's going to become very important in a few minutes. Okay? Reciprocals. We like reciprocals. I do. I like them a lot. Okay. So try the next one. First step. Divide by 3. Second step. Cube both sides. 0 cubed is? Last step. Does it check? Any problems? All right, excellent. No, it gets harder. I'm sorry. Let's try, let's go to, I don't want to do these ones because I know you guys have it, so I want to move on to harder ones. Let's go here. Okay, so just a few minutes ago, we talked about square root of x being the same thing as, and the cube root of x being the same thing as, how about if I have x to the 2/3 power? How would I change that to a radical? Good, cube root of x squared. So really, this can be written as a radical, but we're not going to. We're going to leave it as a fractional exponent. We're going to get rid of it using the what? What's the word? The reciprocal. Okay, so it's solved the same exact way, except instead of raising it to what the index is, we're going to raise it to the fractional exponent's reciprocal. All right, so we first have to do something else, right? Good. We want to isolate this piece right here. So just like we would isolate the radical, we're going to isolate the piece that's being raised to that fractional exponent. So we're going to start by dividing by 2. Great. Okay. How do I get rid of that fractional exponent? Multiply?
The reciprocal. I know what it looks like.
Yes, but you're all saying multiply. When I think multiply, I think doing this. Is that what I want to do? No, absolutely not. So say it the right way. Good, I want to raise both sides to the 3/2 power, because I know when I raise a power to a power, good job, guys. When I raise a power to a power, I multiply. What is 2/3 times 3/2? 1. Yeah, so those go away. Good. How did you get 125, Gia? Put it in your calculator. Excellent. Do I need to give, hold on. Do I need to give you a minute to catch up? Okay, so we get x minus 2 equals 125. Now what? Add 2, and I get 127. So is it really that much different? What do you have to make sure you do? Please check it now. Okay, so I'm going to have you go ahead and try this one, please. First step, guys. Great. Okay. Good. Raise both sides to the 3/2 power. So we get x plus 3 equals, so 140.3 to the nearest 10. Okay, now what? Good, subtract that 3, 137.3. Now, when you checked it, what happened? It said false. Why? Yeah, you see this here? It's a rounded value. It's an approximation, right? So if I go to check this in, is it going to say true? No, it's going to say false because it's an approximation. So the way you have to check this is you could put into your calculator, this piece, and see what you get. It should be incredibly close to 54. That's how you check ones that you're approximating. Okay? Are you okay with that? Do you need to see it? Okay. So 137.3. What was it? No, I forgot. Okay, so is it really close to 54? So does it check? Yeah. Okay. Yeah. All right. Let's get a little harder. Let's try this one. Okay, how would you start this? Subtract that 5 over. Great. We only did one step. Just subtract the 5. Okay, we'll square what? Got to square both sides, right? Okay, question. Good, I have to FOIL it because this is it's a binomial. How do we square every single binomial? We FOIL it. Okay. Ugh. Okay, do you guys know the shortcut for this? Instead of having to FOIL it all out? You know x times x is, okay, -5 plus a -5. -5 plus a -5. -5 plus a -5. -10. -10x. So if you add these two and then tack your x on, those are your center terms. Okay, -5 times -5 plus 25. Isn't that easier? So add these two and then multiply these two. That gives you your middle and last terms. Hold on. All right, so we have x minus 3 equals x squared minus 10x plus 25. This is a quadratic. What do I like to do with quadratics? Get them equal to 0. So what am I moving? Subtract that x and add the 3. We're doing okay? Do we need to slow down? Okay, slowing down. Wait. Wait. Okay, now what? Factor how? It's -7, -4. So x minus 7, x minus 4 equals 0. So I get x equals 7, x equals 4. But I have to make sure to do what? So please go ahead and check both of those. Now, question. If I'm checking using numerical solve, is it going to check both solutions for me? It's only going to give me one, right? So in this case, I would want to use what? Store. Okay, so go ahead, store 7, store 4, and see if they check. Do they both check?
No.
The 7, 4 gets rejected? There's my answer. I could call my mother. There's my answer. We good? Okay. No. Then. Hey, give this one a shot. Let's see how you do. Your homework tonight is pages 12 and 13. It's the same exact stuff we've been doing. Don't forget, weekly project 5 is due Friday. Your process essay is due a week from Friday. So you have just under 2 weeks to get that accomplished. Okay? Okay, so for the sake of time, you should have Subtracted the 3 over, right? Squared both sides. 5x minus 1 equals x squared minus 6x plus 9. Agreed? Subtract the 5x, add the 1. And we get x squared minus 11x plus 10 equals 0. Factor x minus 10, x minus 1. And we get x equals 10 and 1. Do they both work?
No.
Which one gets rejected?
1.
My only answer is 10. All right, guys, how'd we do today, okay?